Today we are in lesson 40, which is learning to simplify expressions by using. This says three new properties, but there's really just kind of three different applications of the same property, and it's this one: the power of a power property. Okay. The power of a product and the power of a quotient, they all follow this rule, and it's all intuitive. So there's really not three different rules we're looking at here. We're looking at one rule and how it looks in the context of multiplication and division. Okay? So we're going to be looking at the power property of exponents. Who knows what the power property of exponents is? Karis?
Power of a property of exponents.
Yeah, so a power to a power raised to a power, what do you do with the exponents? You multiply the exponents. If you multiply things, you add exponents. If you divide things, we are subtracting exponents. If we raise a power to a power, stop. If we raise a power to a power, then we're going to be multiplying exponents. So here's some things that we've kind of picked up along the way related to exponents. Anything raised to the power of 0 is equal to 1, except for 0. 0 to the 0 is an undefined expression. Yeah, it's not an expression that means anything. So what do we have? Every number has 0 factors of 0. Right, so 0 factors of 0 is kind of one of those one of these. Right? It does not have any shaking my head, scratching my head. Okay, it's something that doesn't mean anything. All right, shh. That's enough. An invisible exponent is understood to be 1. Right? Division means we subtract. And there's two variations of this, right? X to the m over x to the n is also 1 over x to the n minus m. So we can subtract in either direction, and we're always going to do that whichever way it is advantageous to us. Okay? X to the m times x to the n is x to the m plus n. So when you multiply, you add exponents. And negative exponents flip things. All right, so the power property of exponents, you guys have already mentioned this. The power property of exponents says that if you raise a power to a power, you multiply the exponents. So x to the m raised to the n power is equal to x to the m times n. Okay, so that's easy, and that's as long as x is not equal to 0, right? And I'm not so sure that this property is different for complex exponents, but I'd have to put a little thought into that. So simplify this expression. 2 to the third raised to the second power is, if we just apply the exponent, that would be equal to what? 2 to the sixth. And we're going to simplify that. What's 2 to the sixth?
4 times 4.
Nah, you need to know this, right? 64 is correct. Again, it's a good idea to be familiar with the powers of 2 up to 10. 2 to the 10th power is 1,024. All right? So 2 to the 6th there's a couple different ways you could look at it. It's 8 squared, right? It's 4 cubed. There's a lot of different ways that we could look at this. It's 2 to the 6th, which is 64. All right? What about a to the 6th raised to the third power?
A to the 9th.
Equals a to the 18th. All right? Now, we're not multiplying, so we don't add exponents. 3 times 6 is equal to 18. We're raising a power to a power, and the power property says when you raise a power to a power, you're going to be multiplying the exponents. Okay? Now, we're going to look at a couple of things here that again, this is all the same thing. They're calling this the power of a product. the power of a product, I feel like we've even kind of already done this, says if you're multiplying two things and raising it to a power, then they both get raised to the power. All right? It is easy. So the power of a product means that it's equal to the product of the powers is really how you would say this. The power of a product is equal to the product of the individual powers of the pieces. So this just kind of applies to problems that look like this. What does this tell us? What does that previous property tell us? Everything inside is being raised to the third power. Every factor inside is being raised to the third power. So this is going to be equal to 7 to the third, which is 343. A to the ninth power, and B to the 15th power. Okay? So 343, A to the ninth, B to the 15th. Now you need to know your powers. You need to know your cubes. Up through 7. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343. These numbers pop up often. You need to know the cube roots and the cubes up through 7. 10 cubed, of course, is 1,000. So you should know those common cubes. All right? Any questions about this? Y'all, pretty easy? Is this a serious question? Or? Okay, what is it?
Why do we have to raise them? Like, what's the point? Oh my gosh. So you don't have to.
It's just what we're learning here again is just a rule that applies to all the way numbers interact with each other. We'll use these rules when we're solving equations and doing other things. So this is almost like this is the equivalent of grammar rules, right? Grammar rules for sentences. You just have to know how different things relate to each other in math, and this is one way that things can relate. So we can multiply things, we can divide things, and we can raise powers to a power. That's the only three things that change exponents. Right? So these are the rules of exponents and how they relate to each other. What about this one? Negative 8y to the 12th, right? Because negative 2 times negative 2 times negative 2 is negative 8, and 4 times 3 is 12. So negative 8y to the 12th. All right? What about, let's skip that one. What about this one? Family room is being measured for carpeting. If the length of the one side of the room is 2x feet, what is the area of the room?
4x squared.
4x squared. Now we could look at that as a product, right? 2x times 2x. We could also look at it as a power, where you square each piece. But either way, you're going to get 4x squared feet squared. Get your units, okay? 4x squared feet squared. All right, the final one is the power property as it relates to quotients. So if we're dividing two things, what's being divided in this expression? X is being divided by y. So the power of a quotient is equal to the quotient of the powers. So we can apply the exponent to the numerator, apply the exponent to the denominator, and we get x to the m over y to the m. It just works exactly the way we would want it to work. There's no fanciness in any of this. So 2x over 5 squared would give us what? 4x squared over 25 is correct. All right? You square each of the pieces. So this is actually the quotient and product rule all coming together because we raised the 2 to the second power, we raised the x to the second power, and then we raised the 5 to the second power. All right, so each piece or each factor on the inside gets raised to that power. Okay? All right? What would this one be?
X to the 8 over
there's some confusion, right? So the confusion is over what we do with the negative. Now keep in mind that's really a -1, right? Okay. What do you get when you raise -1 to the 4th power? +1. It's an even number of negative signs, so it's going to be +1 x to the 8th over, what's 3 to the 4th? 81 y to the 12th, right? Now we got to make sure nothing can be simplified, and it can't. That's what we come up with. Again, this is a nice lesson 40. Lesson 40, the lesson before our test. Okay? Now, properties for exponents. The rules for exponents properties apply to expressions with powers. When you're simplifying expressions, be sure that you follow the order of operations. So anytime we are dealing with expressions, algebraic expressions here, we want to follow the order of operations. That means we'll do exponents first, then we'll do multiplication and division, what's inside parentheses, exponents, multiplication, division, and then addition, subtraction. So a problem like this, it's important that we do which operations first. Write this down, everyone. Some of you guys have just been watching today, and that's okay up to this point. This is not a problem you need to try to do mentally. What operations are in play here? Exponents, multiplication, right? There's really nothing that we can simplify inside the parentheses. So these parentheses here are just there to show us that we are dealing with multiplication of two things, right? Each of those things is being raised to a power of 2. So what we get when we raise the first power of 2, power to 2, 16 x squared y to the 4th, and that's being multiplied by 4 x to the 6th y squared. And now we're going to switch rules, right? Because now we're not raising a power to a power, we are multiplying. What do you do to exponents when you multiply? Now we're back to switching rules, and this is where it gets. You got to pay attention to what you're doing, because what operation you're performing tells you what you should be doing with your exponents. So that'll be 64 x to the 8th y to the 6th. All right. Don't get confused with the operation. Operation that you're doing with your variables, coefficients, and what you're doing with your exponents is never the same. Did y'all hear me? Never. It's never the same. If you're multiplying coefficients, you'll never multiply the exponents at the same time, right? If you're raising a coefficient to a power, you're not going to raise the exponent to a power. You're going to be multiplying the exponents. All right, so just kind of keep that in mind. Last example. What are we going to do first here?
Solve the power to a power. Simplify the power to a power.
Not the negative sign,
Simplify
the negative exponent. So x to the -2 needs to go downstairs. And then we're going to square that. We can go ahead and do this one, can't we? What's 3x squared? 3xy squared to the 4th power.
81
X to the 4th, y to the 8th. All right. Now, let's square what we've got over here. What's -5 over x squared squared? 25 over x to the 4th times 81 x to the 4th, y to the 8th.
So x to the 4th cancels.
The x to the 4th cancels.
81
81 times
times 25.
25.
Y to the 8th.
Okay.
I'd rather not do
Was that 2025?
Yes.
Okay, so 2025
that. No, sir.
y to the 8th.
2025.
I think that's right.
It probably is.
Okay. All right. So the reason we do that is because the x to the 4ths can cancel, right? Now, we could have applied the property of exponents directly here. And the first problem, or the first factor there would be 25x to the negative 4, right? Times 81x to the 4th, y to the 8th. And then when you multiply there, you get 2,025. X to the negative 4 times x to the positive 4. X to the 0, which is just 1. And then y to the 8th. All right, so you can do it directly, but as a general rule, I want you to get accustomed to making your exponents positive to do your operations. In a lot of instances, it's going to work. All right, write this down. This is your homework for tonight. I want you to get out your homework from last night. We're going to check it for accuracy at this point. Okay.